All right, so today is review day, and let me see, let's go into Blackboard and see what I have for old tests. Probably the easiest thing for old tests, the closest you can get them, the better. Since it's fall 2021, I only had 3 exams then. Let's see what else. 2020. Yeah, I don't know why there's only 3 tests. Let's come back. If I don't have, I have to bring my old computer down then. My other computer, if I don't find it in here. Some of them have solutions. Here's test 4. Finally, I found one with test 4. And well, if you keep with it, you'll get, oh, look, the solutions are in here. Check that out. See it? This is test 4 with the solutions already there. All right. So anyways, let's see what material we've covered so far. We have been doing, where do I want to go? Probably Alex. Okay, these are the sections that we've done. These are the ones that you need to prepare for this last test. We have been doing exponents and nothing but exponents. So we did 2.1a, 2.1b, 22a, 22b, 23, and 24. Okay? They cover everything was exponents. So let's go to my practice that I had here. This was where fall 2018. I don't see any reason why your test will be that much different. The only thing that could go wrong is if we covered different material, then, you know, I missed a day this semester. We packed things in here. I can't make up a missed day. So I'll see if there's anything you should not be doing. Polynomials. We didn't do polynomials. So that was from 5 on, we didn't do. So we just did exponents. Okay. So it's gonna be all that chapter 2 stuff on exponents, what the whole test is gonna be like. Well, I think probably what's best is I'll grab most of the questions from the textbook. So why don't we grab some of the homework problems, try them out and see how you guys feel with them. And hopefully they're not that big of a deal. Yeah. All right, then ask some questions on it. Where that thing's aimed at. Holy crap, man. All right. I don't want that one, actually. I want this one. All right, so here's our homework problems. Let's take a look, and I'll start in, it's basically 3 homework assignments is what it is. I somehow have to come up with a test that'll be long enough to take with just these number of problems in them. So I go to the preview. Let's take a look. This includes WebEx folks too. You know, if you guys want me to do any of these problems, tell me, because I'm going to yank these problems straight from these homework assignments. Okay. The only problem with yanking, like, watch this, check this out. See what happens when I try to copy it? Doesn't let me have the number part because they use something different to create that part. It's a math space, so I can't copy it. But the numbers will be changed anyway, so that's not really that big of a deal. All right, so what I'm gonna do is pop through these things and you tell me when you see one that you don't like or one that is tough and you need me to do one. Let's see, well, I'm assuming everybody, and that includes WebEx folks too, can all see this stuff.
Can we do this one?
Sure. Oh, I see. There's 2 different questions here. I was confused with the first one. All right, well, let's start with the first one. They wanted you to write that first one without exponents. Do you know what that even means? Well, the other two you write n squared, not using an exponent. Oh, n times n. That's right. So they want you to go n times n. And then what about the n to the third? I see this is one of the earlier ones because how many n's do we see total? So that's equal to n to the 5th, isn't it?
It's like the first one.
Yeah, so this part right here was the first part they were asking you for. And this part was the second part, but we know this much. This is an exercise that was before you learned of a certain rule. What rule do I use to combine it into one exponent? Exponents. Not with multiplication. You add, it's 5 of them, right? How are 2 and 3 give you 5? 2 plus 3. You add the exponents is the rule. I think it's called one of the product rules. But that's what they're looking for there is that guy. So you understand that when they have the same base, you add the exponents. And that's exactly what they tried to do with that first question. Are we okay, everybody?
Yep, we good. Thank you.
Okay. Let me just make sure that that is what they were asking for. I like to check just to make sure I understood. So this was N, are they using dot? Oh yeah, well, here they are. Look at this. 2, 3, 4, 5. Oh, we got 5 of them, and this one was the 5th. What about this one? Anybody tell me just by looking at it what it's gonna be? You can't see it? Let's see, if you add up those exponents, so this first one right here, what's the exponent there? 1. So you take 1 plus 2 is how much? 3 plus 5 more. 8, 9, 10, right? Put it back down to size. All right, so we did actually look at this one, so we might as well throw it on here. People can use this as a study guide. It's funny you should mention because there are some classes where they let the students make up tests sometimes. And the students in those classes make up a test that's harder than the one that the professor gives. Yes, believe it or not, it never works like you think it's going to. We were going, oh, why did that? Oh, let me grab this. That's right. I forgot I was going to write this answer here. Well, yeah, some people think, if a person's getting an A in a class, he's going to be like, so this y here, this is really y to the 1 times y squared again. So when you do all of this, you're going to have 1 plus 2 plus 5 plus 2. All that is in the exponent. You have y to the 10th. Questions about that? Okay, we're good. If you get stuck, let me know because we have time. We're not pressed for any time. I think you got to press. If I do y, I think I got to hit this. Yes, and then it'll let me put this up here. I believe this is on the product rules. Quotient is a division. Keep that in mind. So yeah. Yeah, something like that. Let's take a look here. What about this one here? Do we need to do this one? Or are we good on this? Can you do it in your head, anybody? Oh, you need to see it. That's right. Well, the people in WebEx land are probably the same way. I think, because if you ever seen their version, you've seen it before, right? How small my writing looks or on their screen. Can you guys do it in your head? Nope. It's not 11. Nope. It's not 11. Right. It's not 11. What is it? 3 times 8 would be.
24 y.
That's right. 24y to the 8th. Yeah. It unfortunately, yes. But you're in the classes that are to come. I don't know how far you're going to go in your math, but you'll use them so often that it won't seem like you're memorizing them. Yeah. So the negative times the negative goes away, right? They cancel. And so we're left with 3 times 8y to the 7th. Now you can move things around. You guys remember why you're allowed to move the things around? Not quite. I'm used to properties. There we go. I'm going to put a 1 up here because I think it's helpful. And then we get our 3 times 8, which is 24. Y to the 1 plus 7. 24 to the 8th. Okay. Actually, I don't want that one. I want this one here. Okay, moving on. Oh, I like to put my answer. Anybody?
Four x four x 4 times x times x times x times x times x.
I have a feeling I should do this one. We put it back to normal size. You want to know what a famous, I don't know if it was scientist or mathematician said about humans. They go, the demise of humans will be their failure to understand how exponentials work. So that's a pretty heavy statement, isn't it? That's because all the bad things seem to grow exponentially. All right, so let's see. We want to write this without exponents. What does the one rule say? Let's look at the first half of the two. What does the rule say that we do? We have one rule that says we have 2x squared third is 2 to the third x squared. That's one of the product rules. What's 2 raised to the third power? Down here to help me with this one. When you do x squared to the third, you do x to the 2 times 3. That's another product. I think it's a power. And so we end up with 8x to the 6. Two to the third was 8. Well, they already got the x there, so all I got to do is put an 8 and a 6. I think they wanted you to do it in a slightly different way than I did. I think they expected you to take it and multiply it by itself 3 times, because this was early on in our stuff and they were still trying to teach you how this stuff worked. So anyways, an 8 would go into that spot and a 6 would go into that spot. Let's go ahead and do them. So if they wanted you, I don't know what they wanted you to do. I think they wanted you to do 2x. Oh, it doesn't have a square, does it? Oh, without exponents. Sorry, I didn't pay attention, did I? No, without exponents. Well, there's several spaces then. Let's redo this. I wasn't paying attention. I hate when I do that. I don't think I would pass this class if I were taking it. We're still trying to get you comfortable with it. So what I think they were intending for you to do is something like this. 2x squared and then you can gather up the 2's to get your 8. What I think they wanted you to do is break all of those x's down. And then they wanted you to gather them up for the second. You see how they looks like that's what they wanted you to do. Like next line, you can gather up your x's. Thanks on the second part. All right, so this part right here, this 8 with 6 x's is what I'm going to do for the first one. Let's see if it's right. Do they have this thing? Yes. 1, 2, 3, 4, 5, 6. And then here we'll put an 8 and a 6. I guess so they liked it. What's this? Do you guys know this? You should know this one right off the top of your head. No, you don't add those exponents. When you take a power to a power, you multiply. That is u to the 20th power. Remember, you multiply those exponents. So does everybody understand? I did 4 times 5 to get this 20. You guys good? I probably should put it in there. Do you think? I think I should put the question in there. Because if people use my thing for studying, well, of course you have this video available to you, but I don't know who. I'm under the impression, you like sit in your living room and rocking in a recliner or something, watching my show. It seems like a very relaxing way to do it. All right, so we have u to the 4th, all of that raised to the 5th. Now the rule, we take u to the 4 times 5, I believe it's called the power rule. It's one of the powers. There's more than compare with the other one. What do you do with those exponents now? You see the difference? They're different. That's right. What I think they were trying to get you to do at the same time, probably because it was early when we were still learning about this, they probably wanted you to write this out u to the 4th times itself 5 times, and then start collecting everything. But since we know what we're up against, that early stuff isn't that big of a deal to me. Let's see what else we have up in here. I'll leave them large if I can, and we'll decide. What about this one? Anybody? Can you do it? And can you do it? You should be able to do it in your head, I hope. Use your rules. What's 4 raised to the 3rd? $32x to the 3rd is close, but not quite. 4 to the 3rd is not quite 32. 64x to the 3rd. Do I need to do this one? Okay. The more I do, the more I earn my paycheck. All right, so that's right. We're going to do, the rule says we take 4 to the 3rd times x to the 3rd. So this is a product or a power rule, I'm not sure, but we take 4 to the 3rd dot between them. 7. 4 raised to the 3rd power is 64. I got a question for you here. This might interest you. of all this, if a student does everything right, but they somehow manage to get this question wrong, what do you think that the one wrong little thing they did was? They wrote 12x to the third. Do you know how that happened? 4 times 3. I always distress because I know they know better, but tests is where you're supposed to show somebody you know something, and you do something like that. All right, moving on. I say that to hopefully prevent you from doing the same thing ever. Oh wait, I didn't write my answer, did I? Let's move on. I have a feeling this one's going to be asked, but can you do it in your head? You don't, I keep saying that, to see if you have it well enough to where you're that good with it. But if you're not, write it out. How much number are you going to have?
16.
You're going to have 6. Do you understand? You're going to have 16. Not 10y. Don't say that way. Y to the 10th. Right.
Yeah, y to the 10th, and then you have
That's right. So did you hear all that? 16 y to the what? 10th. U to the 13th. So with these things, if you have to, it's not a bad idea to rearrange things, because you're allowed to rearrange things because it's commutative. So what I would do is I would rearrange it. I would have 2 times 4 times 2. Those numbers would be out front. And then I would collect the y's together. Y to the 1. To the 5th. I don't know if you need it, but these were all multiplied together. Now I gotta do by my numbers. There's where you get your 16. Y will be raised to the 9 plus 1, raised to the 5 plus 8. So that's 16 by 10. I did not hear what they said. Okay. I'll assume they just had a microphone on. They shouldn't. All right. Would it be weird if you saw somebody in my office right now? That spooked me out, like some shadow figure. Then I would know. I would know they're up to something, wouldn't I? We see a 16 y to the 10th. There it is. I don't think it should require you to have a multiplication. Oh, I guess it doesn't even want you to. U to the 13th. Eventually, I think this repeats after a certain amount of questions. How about this one here? Write your answer without parentheses. All right, you take everything inside, raise it to the 4th power. Do you know what a -3 raised to the 4th is? That's -3 raised to the fourth power.
So the negatives goes away.
I'm sorry, what did you just say to me?
It's even, so the negative.
Oh, yeah. I didn't quite catch it. Yeah. The negative will get wiped out because of the even exponent. That's right. 81, that's right. You want to say b to the 7th, don't you?
I wanted to, but.
Give ourselves some space here. All right, so everything gets raised to the fourth power. Then we have a to the third raised to the fourth power. As you mentioned, the negative will go away because it's raised to an even power. 3 to the fourth is equal to 8. A to the fourth didn't have parentheses, so it's good. And what do you do with the exponents for b? Put them together, so you're going to have 3 times 4. Questions? We good? Ooh, this looks like a good one. What do we know about these things? You apply that exponent to absolutely everything inside of there, don't you?
So why to the 8th power over 80 to 16th power?
Y to the 8th over 81 x to the 16th. So you apply everything that gets raised to the fourth power inside of there. To the second times 4. That, and then you have 3 to the fourth times x to the fourth times 4. Let me rewrite that. I got this stuff blocked. I have y 2 times 4 divided by 3 to the fourth. It's the fourth times 4. I'll stop there. You guys understand what I did? I don't know what that rule is, a power rule, I think. And so now all I got to do is my multiplications. Y to the 8th divided by 3 to the fourth is 81. X to the 16. As you get better with these, this is the kind of thing that in a couple semesters from now, you'll look at it and you'll just write the answer down. We good, everybody? Okay.
Yep.
Good. I think in these we can do this. You know, by the way, I don't know if you were doing this homework, but if you hit Shift caret, it'll bring you up there anyways. Did you know that? Shift 6. Hey. What do we have? X to the 16th? You could probably do the whole thing without using any of these. What's next? I got 13, 14. There's a lot of homework here. It doesn't look like I've repeated any either. Did we do one like, we didn't do one like this. It just gets progressively, oh, this is a good section for homework. Let me open this. Let me move these people out of the way. Well, up to 22 questions. Okay, and there was no repeats as far as types of questions. So this is a perfectly valid type as well. Anybody think they have a shot at this one? Why don't you take a minute and see if you can do it?
Yeah. Yeah.
I don't suppose moving up would be an option.
It would be, is it, 3x?
Where are you getting the 3 from?
Two, you got that 2, and you got this -1. 2 is gonna become a 4.
This is multiplication though.
Oh, that's on the.
There's no plus between there,
Alright,
is there?
yeah. Alright, so now we got 4 x to the, so -4x to the 8th.
Uh-huh.
Oh. Six, 4 and 6, 10, y to the 10,
Uh-huh.
and b to the.
That's right, right, exactly right. So let me go ahead and grab it. Right, so in the first part, everything is taken to the third power. It's taken to the second power. So that -1 gets raised to the third power as well. Remind us that we are multiplying. Everything in the second parentheses gets raised to the second power. And so -1 to the third is just -1. I have y to the 2 times 3. Z is 3. So 4 times 2. So 2 times 2. Let me simplify a little bit more there before I start moving around. Okay, I'll move things around. I can use commutativity for that. So I start with -4. I got y to the 6th times y to the 4th. Z to the 9 times x to the 8. And then there's only 2 that have the same base, so I'll add those exponents. And if you like yours to appear x, y, z instead of that, I can. So either way, if you, however these are mixed around, it's fine. I guess, oh wait, I can probably do this. Let's see, did you even see the thing on it? Okay. Beautiful. This I'm going to skip because it's really slightly less difficult than the one we just did. So I will leave you to it. It looks to be like they're repeating, though, doesn't it? Yep, all these are the same as the first. Okay, so you can try the second half. It's exactly like the first half, so I can pop out of this thing. All right, so that's the questions from homework number 1 for this. There was only 3 homeworks. Review this one. 20 questions. So that might be, a lot of times I ask the same questions over, like the same set of questions several times just to give you enough practice. What about these things? Any number raised to a 0 is what? Except for what number is not allowed? Right, you cannot do 0 to 0. Can you tell me what this answer for the first, where the cursor is blinking at right now? Can you tell me what that answer is going to be? Because this whole piece, 1/3 raised to the 0 is how much? 1. So you have -2 times 1. How about the second one? What do you think that answer is? So remember your 0 exponent rules. Now this is when we shifted now. We expanded our exponents to include negative numbers. Do you remember how to make the exponent change into a positive number? No. Did you say 2/3 over 1? 2/3 over 1 is equal to 8. Is that what you meant?
Yeah.
2 to the -3 is 8, you think? You do, but that's not the same as the number 8. That's right, it's 1/8. There's a big difference between the two. So remember the rule. I don't know if it's called negative exponent rule or what the thing is. But the rule says that you can make it into a positive exponent by doing this. It's not really flipping, it's changing position is more into what it's doing. This is 1. So this next homework has a lot of negative exponents and things like that. All right, we're at break time. What I'm going to do is head up to my office and see if I can find some old tests 4, and see if I can find some to throw up there, aside from just this one, because it's only half good. See what I can find from old recipes. See what we got here. Teaching by 5. Yeah, this fucking test somewhere, but I don't know where it went. Unless I do the same thing. You see in here. Oh, I see. That's how 2020 worked that way. Gotcha. All right, let's see if anything after spring. 2021. Oh, I gave them in, I know what I did with them. Let's see if we can find something from 950 then. We didn't do exponents then. Crap. But I don't have anything more in there than that. Graphs. Was it supposed to have been from? Well, 2019. Why don't I have this information? What would I have made the test at? How would I make the test?
Final exam's probably not so bad.
Right. Remember, a lot of the practice in this section involved making it so it had no negative exponent. What could you do with this one it would like you to rewrite it without an exponent? What would you do to it with that -1 up there? Turn it into 2/9. Do you understand? So when you do that, it'll be 2/9 raised to the 1 power then. So the negative does this, it changes it, takes the reciprocal, but now it's raised to the positive 1 power. And anything raised to 1 is just itself. So this just equals 2 to the 2. Had they given you this one, how would you have answered for your final answer? What did you say? You don't say that's a 9. Now it's raised to the positive 2. Well, now take everything to the second power. 2 to the second power divided by 9 to the second power. 2 to the second power is 4. 9 to the second power is 81. Oh, we already did this one. What about this one? It's a little tricky.
So negative
-1/3 it is. Very good. Remember that -1, which was, it was -3 to the -1 power. That'll equal 1 over -3. And that negative you can put anywhere. Most books will put it right immediately in front of the fraction, like so. Which is fine with me. You can put it up top, bottom, whatever.
That's not.
Yeah, just not behind it, yes. All right, and students you've got to be careful about when these questions, make sure you read them carefully. Does the question care about the negative that is in front of the number 3? No, it does not. What is the only negative this question cares about? The one that's up there on the X, right? So now how do you make that -4? How do you change it? What do you do? You push it up to the numerator. So I don't know, I never know the exact phrase to put it, but it changes levels. However you want to think about it, it moves from one spot up, or it moves up or down. I cannot come up with a good phrase for that. It's not a good phrase. Flip makes it seem like it's going upside down. In my mind, that's what I think of anyways. So the negative that was in front of the 3 is perfectly fine. The negative that was on the exponent, all you have to do then is put your x to the 4th up here. And you should be able to put your -3 down there if you wanted to. I don't know what this homework system is going to say when I do that for my answer, but let's find out. So we have, my answer to this is x to the fourth divided by -3. I took it. Questions on this? Okay. I know there was 22 questions, so if we get to probably 11 and 11. No, it's faster than that. We did this one already, so we've already exhausted this. Can you tell me what these answers are going to be? What do you get for the first one? 3. What do you get for the second one? 1, right. Do you guys understand why 3 is the first answer? All right. So it's going to repeat. So you get a chance to do all those types of problems I did just now again. So it basically just repeats the same problems again. Are there any questions about this? Now, the big one, the one that they call tying everything together was 2.3 and 2.3 was actually the big one. I didn't mean to do that at all. What did I do? Yes, leave. What the heck? Oh. I don't know if I want to take that out or not. Do you guys get logged out of Alex? If you're out there for like 5 minutes, it'll log you out. Make sure. Two 2.3 kind of puts everything together, as they say. 25 questions. All right, and as I'll do like the last time, if they're easy looking, I don't need to bother doing the easiest ones if you understand them. But if you want me to do them, you need to let me know as I scroll by them. And it should be easy enough to where you should be able to do this in your head, I would think. Anybody think they know it by looking at it? Not as easy as I thought, I guess.
2BC over 3CD.
Right, and you can simplify it though more. It's not quite completely simplified. So you have the 2 over 3, so 7 canceled out between the 14 and 21. So all those canceling still work like they used to. If I take a 7 out here, I'll get 2 and a 3. Be on the top, but these C's should cancel. So I'm going to have 2B in the new, 3D in the new. Yeah, yeah. How about this one? Remember, with these things, we'll probably ask you to simplify it, but to do it without negative exponents. So keep that in mind. Most problems will ask you to do it without negative exponents. So don't write them anything with negative exponents if you can help it. This is the quotient rule in action. What's your answer?
Say 1, 1.
Hmm? So we had the y on top has an exponent of 1. Rule says we can do this. I can take this one down below and write it as y to the 5 minus 1. You remember? That is unfortunate because that's like. So remember, if we had something like this, if I had the same base like this, the rule says that I have a to the m minus n. By the way, it also says this. That is also the same as 1 over a to the n minus n. Almost certainly one of those will have a negative exponent and the other will not, so you just simplify it. But anyways, we end up with 1 over y to the 4th. Another way that if you get a chance to check yourself on these things very fast. Another way you can look at this here is if you have y. This is the same as y. It's y. 5 y's down there. If I take one y away, how many y's are left? I don't think they expected you to write y to the negative 4, so I'm going to write it just to see what it says to me. So I'm going to try negative 4 like that and see what happens. Ah, look at it. It's angry at me for using negative exponents. That's right. That's what they're looking for, and that's all there is to it. This one is no different than the first problem. Try this one. Seven over u to the 4th, exactly right. So what I do in my case, and I don't know if you saw this, but I'm going into 63 all the way. 9 goes into 63 7 times, but what I do for this is I usually wipe this out and then do this. So this shows all my work and slashing and everything like that. So then when all is said and done, all that was left in the numerator was a 7, and all that was left in the denominator was u to the 4th. Questions about that? Remember, on these homework problems, you can try them over and over and over again to your heart's content. So it allows you, anytime you get one right, it allows you to try to do it again. What did I do wrong? That's right. What'd you say?
2z over 1.
Not 2z.
2z to the second power.
Right, right. So the d to the second or z squared. So when I take out this z here, that's z to the 1 power. I can wipe that out, so I'll make 3 minus 1 up there. I can wipe out this y to the 6th, and so long as I do 7 minus 6 down there. Up with z squared in the numerator. Divided by y to the 1. And you don't need that 1. It'll just, I don't know if it cares whether you put it or not, but I wouldn't put it. So we had z squared divided by y. That is y to the 1. And let's check it. Yep. You can see it's the same problem, but they just keep adding a little bit to it each time. So it's just a little bit harder each time. These problems will be the bulk of your test. You know, this simplifying will probably be like 50 points or something. You can. Something goes into both of them. What goes into both 49 and 14? That's right, 7 over 2 for that part. Exactly right, right? I don't know what that noise. Oh. I turned it is, but my office, it's coming through my office. But I turned my microphone off up there. So I don't know why it's doing that now. It was repeating. Who knows? What are we doing here? Oh, yeah. 7, all right, so 7, we got 7 over 2. Now what about the x's? Where is it at? The bottom, right, x to third. Right, exactly right. Once you get the hang of these things, it starts to get really easy in that realm. I personally, if I would do this problem on my own, I would do this. I would rewrite it, because I always think it's a good idea. This gives me plenty of space to do my simplifying. So like I'll start with the 49 and 14. 7 goes into that. To both of them. X squared, you can wipe this out, but you put minus 2 up there. So I'm giving myself room. And then this y to the 1, wipe it out and put minus 1 up there. And so in my numerator, what all do I have? 7 y to the 4th. What do I have in the denominator? X to the 3rd. Essentially, yeah. That's right. That's exactly right. The only thing is that kind of thought process becomes confusing when we start throwing negatives in. It gets more cumbersome then. What do we got? 7y to the 4th over 2x cubed. 7y to the 4th divided by 2x to the 3rd. Make this bigger. Oh, this is a good one. Are you sure? Well,
Well, no, but keep it there.
so you're not really all right, wait, first of all, you know you can switch them, right? And it becomes P squared over P to the 1. That's not done though. We have second P to the 1. Everybody's good with that? What you're doing then is this. Just P to the first. You can put it or don't put it. I don't think it cares. It's the same, it's right no matter what. Well, let's see if it takes P to the first.
That was smooth.
Oh, thank you. P to the first, let's check it out. Yep. However, by convention, exponents of 1 are not written. Ooh, that's a good one. This is now when they're starting to get enjoyable. For probably me and not you. Take a few minutes on this one. You do need to try some of this. This is close to as difficult as they get. It actually simplifies very, very easily. What you got? B to the 9th. And you don't have to have the 1. It's just B, right? So it's B to the 9th over 3A. That's right. B to the 9th over 3A. That's right. There's a variety of ways to actually go about it. First, what I would do is cancel the numbers. So like 5, for instance, going to 15 3 times. And then my next step would be to wipe out all those negative exponents. So like I would have my B to the 8th, which was up there, I would keep it. And then I put all the negative stuff. Let me pause there. Do you understand all this that I did? I simply moved around everything so the exponents were not on. That's one way to do this. And then when we do our simplifying, we have BA times B to the 1 is B to the 9th, 2A plus 1. And the denominator, I'm going to wipe this out and put a minus 3 up there. So B to the 9th, 3A to the first. And I'll just leave it as 3A. All right, let me give you one. You're not right. It is 1.
So it's still gonna flip. So the negative, it's 3/2.
All right, stop for a second. What is negative 0 equal to? 0. It's still 0, isn't it? Isn't negative 0 still 0? The 2/3 to the 0 power, which is that version of it. You probably, hey, we can make the exponent positive. By doing that, what's that equal? So what I think is funny is that your first instinct was not to say that negative 0 simply equals 0. But you're thinking of all these rules and they're cluttering obvious solution, you know what I'm saying, obvious facts. That's what happens when you get all these rules and shoved at you at one time. You completely forget simple things. Yeah, like 0 equals 0. Exactly right. Yes. This one was what? Was it b to the 9th? This seems like one of our earlier ones, doesn't it? It doesn't hurt. Why don't you guys try it? But I believe it is one of the earlier ones we did. Uh-huh. 40W to the 9th, U to the 11th. That's right, exactly right. So the way you do it in your mind is, I don't know how you do it in your mind, but one way or another, this is what you do when you do it in your mind. First, do 5 times 2 times 4. And you probably put the W's together, so you had W to the 8th. Five times 2 times 4 is 40. What do you do with these W's? What do you do with those exponents? Add them. So you get W to 1 plus 8. Same with the U's. U to the 8 plus 3. So we have 8. Notice all those exponents were positive to begin with. Let me just make sure these problems are starting to repeat so I can move on to 2.4. That was 40 W to the 9th. Let me see if they're repeating here. Did we do one like this yet? I don't think so. Did we? Well, it would be problem 2. Let's see. I don't believe we did. So they've been getting more complicated. They have not been this bad yet then. All right, so we're still finding out new ones. Yeah, we have not done this type yet. So why don't you take a few minutes on this? Due to time constraints, you know what, I'll tell you what, due to time constraints, I'm going to take over and just do them. But I'll probably ask you to see if you're paying attention while I do it. For a problem like this, you realize you want to take everything to the second power, correct? Do you also realize that a great deal of simplifying can happen before you do that? Look, doesn't 2 go into 6? Doesn't y squared go into y to the 4th? So I can do a great deal of simplifying before I even take anything to the second power. I can take this 2 out. I can take the 2 out and turn it into a 1, change that 6 to a 3. And then if I take this y squared out, I'll have y to the 4 minus 2. See that? I'll rewrite what I have here after my simplifying. I have x to the cubed y squared second power. And so now you can erase everything inside of there to the second power. So you can have like y cubed to the second, y squared to the second, What's x cubed to the second? X to the sixth, right? So you're gonna have x to times 2 up there. 2 times 2, that'd be y to the 4th. Almost done. X to the 6th, y to the 4th.
This shouldn't be too bad. One.
What do you think about this one? What I probably would do is handle the exponents first. So what I would do, that's a 1. I would write it as v to the 2 minus 7 plus 1. You agree that that's with that? Still on the same base. How would I end up with then is v to the negative 4th. It's equal to 1 over v to the 4th. That's one way. Some people may opt to do it this way. See what I handle? But I wipe out first the negative exponent. Now you can work the other with any other problem. But b to the 3rd on the top, b to the 7th on the bottom, and then you'll use the quotient rule. Get it. So either one of those ways will be perfectly fine. And there may even be more than I'm not showing you. Similar. I would do it the same way. It's weird. I can't give you a statement here. I can't say that you do just this or you do that. As I do them myself, I'm going to gather up all my things first, get positive and negative exponents, and then I'll handle the negative exponents later. Sometimes when I get a problem, I feel like handling the exponents first. I don't know that I can give her why or wherefore. It just looks so easy to gather everything up first in this problem. So like, I'll put all the numbers together, I'll put the W's together, I'll put the Y's together. So what I'm saying is I'll take my 2 times 4 times 4, that's this guy, and this guy. I'll take my W's, I have a W to the 8th, that's going to wipe me. W to the 4th. Take that one out. To the negative 8. y to the negative. So I think that's a smart idea to first combine and get everything together. Tell me for the number part at the beginning, what do you get for that? You get 32. How about these w's? W to the what power? Plus 4 gives you the 12. That's right. How about b to what power? Negative 8 plus 3 is negative 5. And then y to the what power? Y to the what power? Good job. Y to the 0. Negative 1 plus 1 is 0. And now I'm ready to, all I got to do is move the v. Everything else is in good spots. So I have 32, w to the 12th, v to the 5th. If I try to put y to the 0 in my answer, I will get it wrong. Why will I get it wrong? What did that thing tell me about the exponents? No. Write them with only what kind of exponents?
Oh,
Positive, and 0 is not a positive number. Are we good with this? With time constraint that I'm under, if you're not good with it, you'll have to contact me later. Ooh, this one shouldn't be too bad. What do you, this should be a one-step problem. No, you're doing too much. No, it's not B to the, where are you getting second from? What's the rule on these things? You multiply them, don't you? So if you multiply them together, what are you going to end up getting? V to the positive 35th power, correct? You can do what you're going to do, but you're going to take a while to get there. So we have v to the negative 5 times negative 7. That's the power rule, which is v to the positive 35. That's what's unfortunate about courses like this. And plus the fact that we have to run it in a semester, it's all about memorizing, it feels like. And you know, what's funny is mathematicians like me have bad memories. So the only reason I know them is because I do them all the time. That's right. How about this one? There's multiple ways of doing it. I probably, so many ways, and so many ways that don't seem that bad to start either. You could start by taking out this negative 2 up here. You could simplify inside of here. So what I do recommend that simplifying inside the parentheses first, because then you're working with smaller numbers a lot of times. So what I would probably do is this. I would go 3x to the 6th divided by y to the 4th. You understand that? See what happened? Got the negative on there. Now I'm going to wipe out that negative 2 exponent by doing this. Y to the 4th divided by 3x to the 6th. Now it's to the positive 2. This is good. I don't have to worry about negative exponents ever occurring now. Got that part handled. Now you take everything to the second power. So that means y to the 4th will be raised to the 2nd. 3 will be raised to the 2nd. A lot of times students forget about that number. And then we have x to the 6th raised to the 2nd. So what do you get for the y on top? 8. X to, that's right, man, x to the 4th, very good. There's one similar to what I was just doing. Let me see. Oh, yeah, let me do a really bad one. Oh. How weak. That was when I got to that one's not as bad looking as this one here. Let's do this one here. And I'll mention scientific notation. All right, so as I mentioned before, I would probably go and I have no idea. I didn't click on it. I didn't mean to click on that thing. All right. So there's a variety of ways of starting. I probably might do this. Get rid of the negatives of anything. So like this m to the -2, I'll put it down here. So you can keep track of them as you're going, I guess, right? And then I have an n to the 5th. That's that one. Then I got a p to the 4th, which I'm happy with it where it's at. But then we got this n to the 5th coming up here, don't we? And I got this p to the 3rd up here. And all this is to the 5th power. So I'll pause there. You guys follow what I did right there. I just cleaned out all the negatives. There's more than one way to do these. Had that 5 been a negative on that exponent, I would have flipped the thing first and then started doing this business. Now, how much n do I have? N to the 5th and n to the 5th. N to the 10. How about p? P to the 4th and p to the 3rd. P to the 7th, right? And then stem squared, right? All of this is raised to the 5th power. That's exactly right. So you're going to have n to the 50th, p to the 35th. 10. 2 times 5 is 10. And the last component of the test would have been scientific notation. That's where scientists, this is an agreed upon notation internationally. That's where we start dealing with things, not this, but I'll get to it. That's the start of it. That's not where we're going though. These you can do on your calculator. Do you know what this means? To turn this into standard notation, what do? So standard is, it's in scientific right now. And they want it in standard, which is the regular notation you're used to. So what do you think this means? Well, what is 10 to the 2nd power equal to? Anybody know? It's 100. 10 squared is 100. Now, 100, if you multiply a number by 100, you move the decimal to the right 2 places, don't you? But we can also forget about taking it 2 places. When you see this 2, or was already telling you to move it 2 places to the right, isn't it? That 2 is telling you take this and put it over into there. What if what if the problem you were given was this? 2.88 times 10 to the -2. How would you change it to standard notation now? To the left. Now, if that exponent's negative, the exponent goes 2 places to the left. 1, 2. So it's 0.0288. And I always put a 0 in front of them. So notice what the positive versus the negative exponent does. Positive moves things to the right. Negative moves the decimal to the left. But you'll have to do some converting in and out of standard notation, in and out of scientific and standard notation. You know how to put a number into scientific notation. Let me see if I can find one here. I'm sure the next one is going to be that. No, Brian's wrong. That's just getting used to the sizes of things. Here's a question. Can you do this one? And you want to write your answer in scientific notations. This is a cute little problem.
Five X to the 12.
Close. Right. So you understand that X in these problems is a multiplication X, right? And you see those X's, they look different than X's that we use. Scripted more. So this is just multiplication. I don't like it, but it is what it is. So you're right. We can multiply the numbers together. So I can do the 7 times 5. And then I can do 10 to the 6th times 10 to the 4th. So I get 35, 10 to the 10th. You can see how it looks bad, doesn't it? I don't have a dot there. Or an X or whatever. Now your job, sorry, I'm making, I'm not putting this. Now your job is to change it to scientific notation. That means your answer is going to look like this. You gotta figure out what power 10 is raised to. Scientific notation requires you to put the decimal right after the first non-zero digit. So what is this new exponent up here on the 10? It is 11. Oh, yeah, I know. That's so silly. All right. Your exam is when? Wednesday. So come here and you can use obviously your calculators. Calculators will be very helpful for the scientific notation stuff. A lot of it'll help you check to see if you're right and everything. After the test, then I will have a review on the following next Monday. You can come and pick up your exams, and then we'll do a review for the final, and then your final will be on Wednesday. Okay? That's all I got. I'm going to sign out.
All right, thank you, Professor. Have a good one.
You too.